multiplication of vectors. So vector multiplication. How do we multiply? How do we multiply vectors? We already know how to add vectors and subtract vectors. The question now is how to um, multiply vectors. So when we multiply vectors, we actually end up with two. One is what we call dot product, and the other one is the cross product. So this is the dot product, and this is our cross product. For the only difference between the two is that this one yields a scalar output, while this one produces a vector output. Now, let us understand further what are the things that we can do with these two. So let's start with the dot product. So dot product. What is this and what are the underlying principle behind this? Suppose we have here vector A, this is a vector A, and then we have another vector B, and they are separated by certain angle theta. Now, the question now is what if we multiply A vector A by vector B using dot product? What if we dot product vector A and vector B? What should be the output? Now, since a dot product end up a scalar quantity, this means that the product of the dot product must be equal to certain value C, and C is again C must be scalar. That should be a scalar quantity. To solve or to get the value of C, we have to use this principle. The underlying logic behind that product is it simply means that how much of let's say vector B is in the direction of vector A. So how much of vector B is in the direction of vector A? Now we know that vector A is along this direction. So our task now is to solve or find how much of this vector B is along the direction of vector A. If I'm going to extend vector A there, and I will draw a perpendicular line here, that means that the value of vector B that is along the direction of vector A must be this one. Let's say this is Bx, and Bx is along the direction of vector A. Now to solve for vector b, we get, and since this is the adjacent, we could use the cosine angle bx over b. We end up with bx must be cosine angle vector b. So this will be the equation that we will going to use in solving for um, vector b along the direction of vector a. Now next step here is we will going to multiply vector a by uh, vector b along the direction of vector a. Now what we get is vector a cross cos angle b, or we would say a dot b must be equal to a bx, or vector a dot bx, which is a magnitude of vector a times the magnitude of vector b times the cosine angle. And this will be our equation in finding the dot product. Now you might think that um, the reference point is unique, such that we have to always follow that A should be our reference point. But it is not the case. So we could change our reference point from vector A to vector B, and we will end up with the same um, equation. So let me show you this one. Suppose I would change how much of vector A is in the direction of vector B. So let me prove to you that the choice of reference point is not unique. So you could change your reference point. So initially we use A as our reference point, but we could also use B and we will end up with the same value. Um, let's say we will going to extend a line like this, okay, and we were asked to solve for how much of vector A is along the direction of vector B. So it means that how much of vector A is along the direction of vector B. And with that case, we will end up with cosine angle AX over A, and therefore the value of A along the direction of B is cosine angle of A. Now, the same process, the same principle, what we could get, by the way, this angle will not change. So it remains the same. That's why regardless of what reference point you will choose, this will not change. So the equation will still remains the same. Okay. So earlier, so A dot B, so we use now AX instead of BX. So this will become AX, or vector A along the direction of vector B, dot b, which will be cosine angle A times b, which will give you the absolute value of vector A times the absolute value of vector B times cosine of the angle. So the equation remains the same.